Hello everyone. Today we're going to be working with the zero product. And what the zero product is you're basically finding the roots of your quadratic. So you're left with a graph, a parabola, and you want to find the x-intercepts, the roots, the zeros, where they cross the x-axis. So we've been doing that with our calculators and using those to figure it out, but now we can figure it out without using our calculators. We don't need to rely on technology anymore because we are competent enough to understand how to find the roots. So what we do, first you want to put it in factored form. So something like this. After that, you have to make sure it's set equal to 0. This one is. It's already set equal to 0. And then next, you just want to solve for each of those factors. So what I mean by that is to write x plus 2 equals 0 and x minus 2 equals 0. So I set both of them equal to 0. And now I just solve for the x in each of them. So if I want to find what x is, I would subtract 2 over for this one. So I have x equals negative 2. For this side, it's x minus 2 equals 0, so I'd add 2 to both sides. That would leave me with x equals positive 2. So my solution would be x equals 2 comma negative 2. That's all it is. Simple. When you can find the roots in this, when you have this factored form, it's really easy to solve the quadratic, to find the roots. It's really easy. So let's do this example of c squared minus 9 equals 0. So the easy way to do it, put it in this factored form. How do we do that? Well, let's look. We have a 1 out in front of the a. The a is a 1. That means we can use the easy factoring method. We don't have to worry about double factoring. So what's the easy way? Well, let's write out the full quadratic, shall we? This is actually c squared plus 0c minus 9 equals 0. So this 0c, that middle term, it was hidden from us because it's 0, so why do you write it down? We don't, but we still need to know it's there. Now you can use the diamond method. So the c goes on top, the b goes on bottom. Excuse me, let me write that 9 a little bit better. Negative 9. List our factors. So we can have 9 and 1. We can have 3 and 3. So what has a difference of 0? 9 and 1 or 3 and 3? It's actually 3 and 3. And the bigger one has to follow the bottom. Well, neither is bigger. But if I put a negative at one of them, it's going to make the addition go to 0 and the multiplication go to negative 9. So that means our solution is x plus 3, x minus 3. Hey, look, it's in our factored form now. So let's solve it. So I have x plus 3, x minus 3. That's equal to 0. So set each of them equal to 0. So I always do a dotted line down so I can separate my two pieces of handwork here. So to figure it out, I want to, for this side with the x plus 3, I subtract 3 to both sides. So that's x equals negative 3. For this one, I have x minus 3. To get x by itself, I add 3 to both sides. So we have x equals positive 3. So our solution is x equals positive 3 and negative 3. These right here would be the x-intercepts. Now, there's another video of just examples if you'd like to see some with double factoring included. But otherwise, zero product is really easy.